In the text lecture right before this video, I gave you a lot of SQL to run. When you ran that SQL, it created 3 different tables. First, it recreated photos and users. They have the exact same structure as what you saw before, but it also created a new table called comments. There's nothing really too new about this comments table. It was put together pretty much as you might expect. Comments has an ID, it has contents, which is the actual text of each comment, and then it has 2 foreign key columns. One relates each comment to a user, and the other relates a comment to a photo. So in theory, this would be the user who created the comment, and the photo would be the photo that the comment was added to. We have 20 different photos, 100 different comments, and now 5 different users. So now with a more complete data set, we're going to start to write out some more complex queries. That's the big focus of this section, and it's what we're going to start to investigate over the coming videos. So now that we have a little bit more interesting data set, we're going to write out some more interesting queries. So things like maybe try to find the average number of comments per photo, or find for the photo with ID 3, get all the different comments for it, and also get the username of the person who authored the comment. We're going to answer all of these different queries using 2 really important techniques, and these 2 techniques are the big focus of these coming videos. So we're going to learn about writing queries using joins and aggregation. Let me give you a couple of notes on these 2 techniques very quickly. Okay, so first off, joins. We make use of joins in SQL queries to somehow produce a value or a set of rows by merging together a lot of different rows from different tables. We're most frequently going to reach for joins anytime you are trying to answer a question or write a query to answer a question related to multiple different kinds of resources. So for example, back on this list over here, you'll notice that the first query says, find all the comments for the photo with ID number 3, along with the username of each comment's author. So this query is mentioning comments and photos and users. Because we are mentioning multiple different types of resources, that might be a sign that we want to use a join. It's not always the case, but if you are being asked to find different kinds of resources, you might think about using a join. The other thing we're going to learn about is aggregation. The goal of aggregation is to take a set of rows or some number of rows and somehow calculate a single value out of them. Anytime you hear the words like most or average or least or greatest or something like that, that's frequently a sign that you're going to want to use some kind of aggregation technique in a query. So a lot of these different items on here mention average number of characters, average number of comments, most activity, and so on. So a lot of these queries on here are signs that we probably want to use some kind of aggregation. Okay, so that's what we're going to be focusing on in the coming videos. In just about all these videos, I'm going to be posing some kind of query or question that we want to solve. We're then going to write out a query to solve it, and then discuss exactly what the query is doing for us. So let's get to it, starting in the next video. All right, my friends, let's go through our first advanced query. The first query we're going to try to write here is to answer this question, or essentially do what this thing says. So for each comment, we want to show the contents of the comment, and we also want to show the username of the person who wrote the comment. And so an example of what we might see is this right here. I want to see just the contents and the username of the person who authored it. So let's take a look at a diagram and understand how we might approach this problem. Okay, so here's our database. First off, there's no mention in that question that we just saw of anything related to photos whatsoever. So we probably don't need to worry about that photos table. In addition, that little query or the question right here is mentioning 2 different kinds of resources, both comments and users. And I didn't see any mention inside there of anything like least or greatest or average or anything like that. So this is a join, or excuse me, this is a hint to me, kind of a sign that we might need to use that join technique that we mentioned in the last video. When we think about the relationship between these 2 tables right here, remember comments has a user ID column. That is a foreign key column that tells us who the author of each comment is. So in theory, if we could somehow write some SQL to take a look at each comment, extract the contents, take that user ID, and look up the related user ID in the users table, that would probably somehow solve this query. Well, let's go back over to our editor really quickly. We're just going to write out a solution for this right away. and then we'll come back and take a look at a diagram to understand what the solution does. Okay, so for this very first one, we're just going to write a solution out directly, and we'll discuss what it is doing for us. So we're going to put in here, select contents and username from comments. And then here's a part that we have not really seen before in great detail. We're going to write out join users on users.id equal to comments.user_id. Now double check everything you've got on line number 3 right here. Just make sure it's exactly what I have. After you double check that, we're then going to run this, and we'll see a result of something like this right here. So I see contents and username off to the right-hand side. Well, it definitely looks like this answers what we're trying to solve. Looks like this query is pretty accurate, but it doesn't really kind of help us understand what this join statement is doing. So again, let's go take a look at a diagram and try to understand what join does. Okay, I'm going to be kind of tabbing back and forth very quickly between this right here and this diagram. I apologize if it's a little bit annoying that I'm tabbing back very quickly, but I just want to refer to different things very quick. So first off, we know that we want some information from both comments and users. Again, that is a sign that we might want to use a join. Secondly, we are trying to refer to some columns or information in both tables. So we want access to contents right here and username right here. Because we are trying to access information in 2 different tables, again, that is a sign that we might want to use a join. So let's now focus on what that query actually does for us. First off, we start off with the from statement. From operates just like how we've seen earlier on inside the course. We could think of from as doing some initial selection of the rows that we want to somehow operate on. So in this case, we are saying take all the different rows from comments. Next thing that gets executed is the join statement. When we say join users, that means that we want to somehow combine information from the rows that we already selected during from with some rows from the users table. So we want to somehow take these rows and somehow match them together with rows from users. Behind the scenes, anytime you see that join statement, you can kind of think or imagine that the following thing is happening. You can kind of imagine that our database is making a temporary copy of that initial table, in this case, comments. And then we can once again kind of imagine that this imaginary table right here gets renamed to something like comments with users. And then finally, we can also imagine that the database is then going to iterate through all these different rows, and it's going to try to match each of these rows together with the row from the users table using the matching statement that we put on the other side of on. So this is our matching statement. This says that for every row in the users table, take a look at the ID and match that up with the row from the comments table, specifically using the value out of the user ID column. So let's walk through what really goes on with that little equals part right there. So we can imagine that our database is going to go through all these different comments. It's going to take a look at user ID. And then for every value inside of user ID, it's going to go into the users table and try to find a user with that ID right there. In this case, an ID of 3. So in this case, our database would go through users, find a user with ID 3, and then we can imagine once again that we're going to kind of copy that user and put them down into this new temporary table. Those 2 columns are still going to have the same meaning as what they have inside the users table. So now we have taken a row from comments and somehow matched it up with the appropriate row out of our users table. Our database is then going to repeat that same process for every row inside of comments. So next up is user of ID 4. Now our database is going to go to the users table, find a user with ID 4, here they are right here, and put them right there. Next, user with ID 2, so we'd put them right there. And then finally, user with ID 1. And user with ID 1, once again. So we can imagine that's what we end up with. We now have this temporary kind of imaginary table, and we can refer to or select any of the different columns inside of here. In this case, we selected only contents and username. We didn't really care about any of the other columns inside of here. So we can imagine that all the other comments, or excuse me, columns kind of fall away, and we are left with just contents and username. And that's what we see in our output results set over here. So I see contents and username. If we wanted to, we could very easily adjust that select statement and select some other columns out of this temporary table. For example, maybe photo ID. So we could try to pull out photo ID as well from the select statement. So if I now run this, I get an additional column there of photo ID. All right. So that is the join statement. Again, we want to think about join statements anytime we're referring to information between different tables. This is not the only time we're going to look at join statements in detail. For the rest of this section, we're going to be taking a look at a lot of other queries that use join statements as well, and you're going to get your own practice with them too. So if join statements are still confusing, don't sweat it, you will get lots of practice. All right, this video is running a little bit long, so let's take a quick pause right here and continue in just a moment. Let's take a look at another basic use of the join expression. So in this example, we're going to try to take every comment, we're going to print out the contents of the comment, and the URL of the photo that the comment was added to. So eventually we should end up with a table like this. Have all the contents, and then the URL of the related photo. Let's first take a look at this in diagram format, and then write out a query to solve it. So here's our database structure. I took off the users table for just a moment. We can once again imagine that we're going to somehow take all the rows out of comments and build up this temporary imaginary table. We're then going to join this entire list of comments with the photos table. We're going to iterate over each comment, take a look at each photo ID, and then go and find the related photo out of the photo table. So in this case, the first comment has a photo ID of 2. So we would take that record right there and put it here. Next up, a photo ID of 3. So take the photo with ID 3. And then finally, the photo with ID 1. That'd be the first one right there. And then finally, we only care about the contents and the URL. So we can just forget all the other columns and only select contents and URL. There we go. Okay, so let's go ahead and give this a shot. Back over here, we're going to select the 2 columns that we care about out of the merge table. That'll be contents and URL. We're going to start off first with all the different rows from the comments table. I'll then join in the photos table. Then I'll put in that keyword on, and then we'll specify our condition for merging these 2 tables together. We want to take a look at the photos ID and get that to be equal to the photo ID column off of comments. So it will be photos.id equal to comments.photo_ID. Okay, let's run this. And there we go. We now get our contents and the URL for each of these different comments. Looks good. Let's continue on in just a moment and try out a quick little exercise around all the same join stuff. We only just introduced the idea of join statements, but let's go through a very quick exercise anyways. So in this exercise, you are going to be given a table of authors and a table of books. Your goal is to join these 2 tables together and print out the title of each book along with the name of the author of the book as well. Let's think about this in diagram format very quickly. So we can again select all the different rows from books and imagine that that creates a temporary table for us, which maybe we would call books with authors. We then need to write out a join statement that's going to take a look at each of these different author IDs and join it with a particular row out of the authors table. So first is the author ID of 2, so that would give us Stephen King. Then author ID 1, then 4. Come on, there we go. And then finally 3, Agatha Christie. And still, these columns would be named ID and name. So now we could select just the title and the name out of that resulting table. So go ahead and give this a shot. As usual, we'll go through a solution in just a moment. All right, my friends, let's go through a very quick solution. So we are going to first get started by writing out a select statement. We're then going to select the 2 columns we care about from this combined table right here, which are the title and the name. So we're going to select title and name. We're then going to tell our database that we want to get all the different rows from the books table. And then for each of those different rows, we want to somehow merge them in or join them together with a row from the authors table. So we'll say join in the authors table. So just join authors. And then we'll say on, and then we'll specify which columns should be used to create the match between each row. So in this case, we want to use the author ID from the books table and match that to the ID column from the authors table. So we could put in here authors.id equals books.author_ID, like so. Okay, so that should be it. I'm going to check my solution. And after a brief pause, yep, looks like it's great. So I could see the title and the name for each of these. Just so you know, your solution will be correct even if you mix the order of these two columns right here. So I could put in name and then the title. In the results set, we'll see first the name column and then the title, but as far as this solution checker is concerned, the results are the same. So you'll notice even when I flip the two, I will see the different order and I still got it correct. Okay, so that's it. Now we've barely even scratched the surface of join statements, so let's take a look at some more around it in just a moment. We've now taken a look at 3 examples of join statements. I now want to give you a couple notes on them, a couple of items that you might be just a little bit curious about. All right, so here we go. Here's our quick list of items that we're going to go through inside this video. So the first thing I want to mention is that the order of tables that we list out in the from clause and the join clause will usually make a difference. Let me show you what I mean. So back over here, I still have the query from when we were joining comments with photos. Take notice how we are first starting off with all the rows inside of comments, and then we are joining in the photos table. In this particular scenario, we could flip the order here. We could start off with all the rows from photos and then join in comments. If I run this, I'll get the exact same result. So in some scenarios, we can flip the order of tables here and we'll get the exact same result, but there are other scenarios where flipping the order will change the ultimate result. Now, your initial question here inevitably is going to be, well, when does it make a difference? I will show you exactly when this makes a difference in the next video or two. For right now, I just want you to know that sometimes it does make a difference and sometimes it does not. Okay, let's move on to the next item. The next thing we need to understand is that if we have 2 column names in the join table that are the same, we have to provide a little bit of context. So, quick diagram. We are currently working with our comments table and our photos table. So we can imagine that we combine the two together into a new imaginary table called something like comments with photos. Now I want you to notice in here, we have 2 columns with the exact same ID. That's ID and ID. We also have user ID that are completely duplicated. Now the values inside of here are not duplicated. It's just the column names themselves. So what would happen if we ask for, say, the ID instead of contents and URL? Let's put in just ID. And if we do so, we'll end up with an error message. So it says column reference ID is ambiguous. Ambiguous means that your database doesn't know whether you are talking about this ID column or this ID column. So if you ever want to select a column that is listed twice or more inside of a join table, you have to be a little bit more explicit. You are going to designate which of those different ID columns you want by putting the name of the table that it's coming from right in front of that ID word. So in this case, we could put in photos.id. If I run that, I'll then be given the ID column from the photos table. So back here in the diagram, it would be equivalent to taking this column right here. That is the ID column that originally came from the photos table. If I want the ID column from the comments table, I would just change the word photos right there to comments instead. And now I get 1, 2, 3, 4, 5, and so on. Now, what would happen if we put in both comments.id and photos.id? Well, unfortunately, the tool that we are using here is giving us duplicate results. That is because not the website I put together here, but a library that is being used to actually communicate with Postgres is giving some erroneous results. If you were to run this query directly against Postgres itself, you would get 2 different columns. But in this case, again, because of just a little library that's being used behind the scenes here, unfortunately is getting a little bit confused on which ID column is which. So even though Postgres is okay with this query, the library that's parsing the results can't quite handle it, unfortunately. If you are ever in the same situation where you are using some library that can't figure out which ID column is which in the result set, you can always rename one of the columns. So I could rename this to as comment ID, and now the result set is more clear. So these are the IDs of all the different comments. These are the IDs of the different photos. Okay, one or two more items. In addition to renaming columns, we can also rename tables using the as keyword. And you're going to see this used fairly frequently on more complicated join statements. So for example, we could on from photos right here put in as p, just p being short for photos. Then everywhere else inside the query, we could replace the word photos when it is a reference to a table with just p. So for example, we could change photos right here to just p. We can also change up here in the select statement from photos.id to p.id. However, if we ever had a reference to a column that had the word photos inside of it, we cannot just replace p there. So for example, on the comments table, if this was photos ID instead of just photo ID, we could not replace photos right there with p. So it's not just a straight find and replace, it is only when we have a reference to a table. Now I can run this again, and I'll see that I still get the same result. You're going to see this shortened syntax or the kind of abbreviation being used, especially any time that you have to embed a lot of different references to your table. One other way that you'll see this syntax shortened up is instead of using the as keyword, you can actually drop off as entirely and write out just photos p. So I can run that as well, and I still get the same result. Now, I personally do recommend that you do put in the as keyword just because it adds a little bit more clarity as to what is going on here. Anytime someone sees the word as, it's just a sign that, oh, something's going to be renamed here. All right, so that's a couple of variations on join statements. The last thing I want to mention is that there are a couple of different kinds of joins, and this is very closely related to the first item back up here. So let's take a quick pause right here, and then we're going to start to investigate the different kinds of joins that are available to us. In the last video, I said very mysteriously that sometimes there is a difference in our ordering with the from and the join clauses. In addition, I also mentioned very mysteriously that there are several different kinds of joins available to us. So in this video, we're going to explore these two bullet points a little bit more. Okay, so here's how we're going to do it. We're going to try to write out another join statement. Our initial attempt at this statement is going to be very simple, very easy, and it's going to be, well, correct. But I'm going to then make a very small change to one of our tables. We're going to add in one record, and then all of a sudden, the query is not going to do exactly what we expect anymore. So here's the goal. I want to show each photo's URL and the username of the poster. And very critically, we must show every single photo, no matter what. No matter how many photos there are in the database, no matter what state or form they are in, we must show every single photo. That's our goal. All right, so if we imagine how we would do this, well, we've been through this process several times now. We could start off with photos. We would imagine this new temporary table of something like photos with users. We would then walk through every one of these user IDs, and for each one, we would take a look at our users table and link up the appropriate user. So there's user with ID 3, and then user with ID 1. And then in our case, we don't really care about any of the columns inside of here except for URL and username. So we would delete everything else, and that's it. Everything would work. So let's go write out this query very quickly. Back over here. Let me just refresh really quickly. And we will do a select URL and username from photos. We will then join in our users table on users.id, and we want to find some record or row out of the photos table with a user ID equivalent or equal to users.id. So we're going to put in here photos.user ID. So let's run that. And sure enough, well, we get the correct result. This is a list of all 20 photos, and we see each photo's URL and each username as well. Now, the key critical thing I want you to remember here is that when we executed this join, every single photo had a user ID value that linked up perfectly with our list of users. So I'm now going to throw a little wrench in this. We're going to insert another row into our photos table, and it's going to break this query slightly. Now, the query is still going to run, but it's not going to fulfill our original goal anymore. Here's what we're going to do. We're going to add in a new photo with maybe a URL of banner.jpg and a user ID value of null. That's the trick right there. We're going to put in a value of null. A value of null means no user owns this record. No user posted this photo. Now, in a real photo sharing application, would this ever occur? Well, possibly. It's entirely possible. Maybe there are some company-owned photos, like the actual app operator put up some number of photos that every single application needs to show for some reason. Who knows? It's entirely possible. Now, your initial concern here, you might say, well, Stephen, didn't we put on that on-delete cascade restriction? Well, we did, but that's talking about deletion of some associated record. In this case, we're going to create a photo with no associated user whatsoever. That is not going to violate any constraint inside of our database. We can freely insert photos that don't reference a user ID. The only problem comes if we start to try to delete a user that still has a photo referencing it. So let's go back over and try to create a new photo, and we're going to make sure we give it a user ID value of null. Okay, so back over here, I'm going to comment out our existing query by selecting all of it and then hitting Command /, or alternatively, you could just delete it and then copy paste it from the query history over here a little bit later on, totally up to you. I'm then going to insert into photos, and I'm only going to provide a value of URL and user ID. We'll then designate the values that we are going to provide. So I'll put in here something like banner.jpg and null. I'll then go ahead and run this. Okay, it looks like it was successful. So I'm now going to delete that insert statement. I'm then going to uncomment what we had before. And then I'm going to run this query again. But before I do, remember one of our big restrictions here, or the big purposes of this query, was to say we had to show every photo URL, no matter what. If it's inside of our database, it must be listed in the output. Okay, so with that in mind, let's now click on Run. It looks like we still get a result, but I want you to scroll through here now. Scroll through here, and you're going to notice something interesting. We do not see anything related to that photo that we just added. We only see the original 20 photos, and we see nothing else inside of here. Now, is that relevant? Well, without a doubt, it's not satisfying the goal of our query anymore. We are not listing out all photos. We are now only listing photos that are somehow related to a user inside of our database. So we're not getting all photos, only photos related to a user. Is this a problem? Again, yes, because it doesn't fulfill the original goal of our query. We might be trying to pull some information about every photo to get some idea of how many photos total there are, or maybe the total storage size of all photos inside of our database. It's always critical to make sure that we fulfill each query that we're trying to answer exactly. And right now, we aren't, because we're not listing all photos. So how are we going to solve this? How can we make sure to somehow join photos with users, but still somehow list out that photo right there? And what's more, why is that photo not being listed out at all? Well, let's take a pause right here and then try to answer some of these questions in the next video. Let's figure out why the extra photo that we just added in did not get added into our join result set. So we're going to take a look at this query as we've done many times and imagine what is going on behind the scenes with the join logic. So inside the query itself, we are first saying take all the different rows from photos. So from photos right there, that's going to include all 4 rows inside this photos table. So we can imagine that this temporary imaginary table down here called something like photos with users is created. We're going to put all the different rows from photos inside there, including the one with the user ID of null. And then the join is going to be done. So we're going to try to mash in or kind of merge in all the different rows from users. And our kind of joining relation here, or the actual criteria for doing the join, is to find a user ID, so something in this column, equal to photos.userid, so something from this column. So we've gone through this process several times now. We'll take a look at first user ID right here. We've got a user ID of 2. That means that we would put this user right here. Next up is user with ID 3. We put them right there. And then finally user with ID 1. And we'd put them right there. Next up, we get a user with ID null. Now in this case, there is no user inside the users table with a ID value of null. So there's no match right here, nothing to match up to this row. The join that we are doing right now is one of a particular set of joins. Remember, I mentioned just a moment ago that there are several different kinds of joins. With the join that we are currently using, if there is ever a row from our source table of photos that does not match up with the row from users, then that row right there gets dropped from the overall results set. So because we could not find a match for that row, we don't see it in the final result. And that is what is happening over here right now. We do not have a match for the user, or the photo that we just added in, and so we don't see it inside of our results down here. Okay, so that kind of explains why we are not seeing that particular photo inside of our result set. But I did mention several times now that there are several different kinds of joins available to us. Let's take another pause here. When we come back in the next video, we're going to take a look at a couple of other joins, which are going to allow us to include that photo. All right, my friends, this video is one that I think you might refer back to in the future. So I'm going to show you a pretty complicated diagram that's going to lay out 4 different kinds of joins that you need to understand. We've been using a join at this point in time called an inner join. So we're going to understand what an inner join is. We're going to take a look at a quick demonstration, and then we're going to walk through 3 other kinds of joins: a left outer join, a right outer join, and a full join. For each of these different kinds of joins, I'm going to show you a kind of complicated diagram, and we'll do a very quick walkthrough. Attached to this lecture, you are going to see a PDF of this diagram right here. You're going to want to download that PDF probably and hold on to this thing whenever you need to refer back to or remember how a join works in the future. Okay, so let's get to it. We're going to discuss 4 different kinds of joins and understand the difference between each of them. We're going to first start off with an inner join. Whenever you use the keyword join by itself inside of a query, that is by default an inner join. So it's going to join these 2 tables together in a very particular way. You can write out either join or alternatively inner join to indicate that you want to do an inner join. So either one, 100% equivalent, either inner join or just join. The way inner join works is it's going to merge these 2 tables together. Whenever there are values or rows inside these tables that don't match up to a row in the other table, that row is going to be dropped from the overall result set. So let's walk through this scenario right here of how these 2 tables would be joined together if we were using an inner join. As we just walked through in the last video, and as we've seen several times now, we can imagine that we would take photos and throw them down here, and then we're going to walk through and try to match up all these different rows to some row inside of users. So again, we've got user ID with 2 right there. So we'd bring that down. User with ID 3 right there. We'd bring that down. And then user with ID 1, and we would bring that down. Now with an inner join, we only keep around rows that match up to a row in the other table. So in this case, for banner JPEG right here with a user ID of null doesn't match up to any row inside of users. So that gets dropped from the overall result set. In addition, you'll notice that inside the users table, there is a user with ID 4 right here. This user did not have any photos tied to them. So we would also not include that user in the result set in any way. Now to kind of visualize this, you're going to see a diagram that looks very much like this right here in a lot of documentation. The idea behind this little diagram is to say that there is some pool or some table of photos, and there is some table of users, and there's rows in both. Only some of these records match up to records inside the other table. And with an inner join, we are only keeping rows that match up to a row in the other table. So the purple section right here is meant to indicate the set of rows that we actually hold on to for the output of the query. So we only hold on to rows that are kind of matching or present between both photos and users. That is where the term inner join comes from, because we can kind of imagine these 2 overlapping sets of rows. We are only taking that inner section right there where we have a perfect match between them. Okay, so that's our first kind of join. And again, it is the default join. If you write out just the join keyword, you are doing an inner join. The next kind of join that we're going to take a look at is a left outer join. So with a left outer join, if anything from the photos table does not match up to the users table, we are not going to drop it off. Let's take a look at what this would look like. First off, we would adjust our query a little bit and say left join users. That indicates that we are doing a left outer join. Then once again, we would take all of our different photos, put them into this imaginary table, and then once again, do that matchup process. So we would pull in 2, we would pull in 3 and 1. And then finally, we don't have any match for this last row down here. But in a left outer join, we do not throw this row away. Instead, if we can't find a match for that, we will instead kind of backfill a row right here, put in some empty values, and they will be given a value of null, like so. So with a left outer join, we do not throw away rows from the source table that don't match up to something on the join table, which in this case is users. And again, we want to kind of picture this as something like this. We're taking everything out of the photos table. Hopefully we can match some stuff up with users, but if we don't, that's fine. We're still going to keep the unmatched photos as well. Okay, let's take a look at right outer join. So with right outer join, we essentially have the exact opposite of a left outer join. In this case, we're going to take all of our different users and include them, even if they don't match up to something from photos. And of course, we're still going to keep all the records that match up as well. To do a right outer join, we type out right join, like you see right there. Now in this scenario, we are still going to take our source table, which is still photos, because that is what we are specifying right here in the from statement. And then we're going to once again go through that matching process. So we get the 2, we get the 3, and the 1. And now here's the interesting part. Any unmatched rows from the left-hand side are going to be dumped. So with the right outer join, we dump any rows on the left-hand side, so from photos that don't match up, but then we include any rows from users. So we're going to include user 4 right here, even though they didn't have any photos. The actual column values for this will be set to null for the relevant post. So there is no relevant post, so we'd put in null, null, and null, like so. So that's a right join, or right outer join. And then finally, the last one we're going to take a look at is a full join. In a full join, we say just give us everything. We don't care whether or not there is any correct merging going on. Just try to merge as many rows as possible. And if we can't, just include all the others. So in this case, we would once again take all of our different photos, put them down here. We would do our best to match everything up. So we would take user 2, user 3. Come on, you. There we go. And user 1. And now we still have the photo right here with ID 4. There's nothing that matches up in the users table, but rather than throw it away, we are going to keep it around. And we're going to set all the relevant columns for some kind of related user to null. And then in addition, we're also going to include this user over here, even though there is no matching photo for them. So we would include this user, and we would give them some values also set to null, like so. Oops, my mistake. Back over here. There we go. So we'd also set them to null, like so. All right, and I'm going to change the color on this to white, just to make sure it's really clear. There we go. Okay, so that's it. That is the inner join, a left outer join, a right outer join, and finally a full join. Now, I got to tell you right now, this is just your first introduction to this, and it is a very complicated topic. So if you're seeing this and you're saying, what's the difference between these, and when would we use any of them, more importantly, this is all stuff that you will learn in due time. As a really quick example that I would tell you right now, why would we use any of these particular joins? Well, to solve the query that we were just discussing a moment ago. Remember, we were just talking about wanting to run a query that's going to show every single photo, even if a photo does not have a related user. So in this scenario, our left table, or kind of our source table, is photos. So if we did a left outer join, that would give us all photos. And it would try to match them up with users if we could. But if there was not a matching user, we would still include the underlying photo. And so this would solve the query that we were just trying to work on unsuccessfully. So all we would have to do is a left join, and we should see that photo appear even though it doesn't have a related user. So there are definitely scenarios where you are probably going to want to use each of these different kinds of joins, and it really just comes down to the kind of question or the kind of query that you are trying to solve. All right, so let's take a pause right here. We're going to come back in the next video. I'm going to show you a quick demonstration where we do a left join to solve the query that we were just talking about. And then we'll go through a quick quiz or two to better understand what these joins are doing. Now that we know a little bit more around joins, let's try to update our query to solve this original question. We want to show each photo URL even if there is not a user associated with them. Right now, with the very simple join that we have, we are doing by default an inner join. So we will only see rows where we have a solid match between a photo and a user. That's not quite what we want. We want to make sure, as we see here with the left outer join, that even if we have some photo that is not matched up to a user, we should see it inside of our output result set. So to do so, all we have to do is convert our inner join into a left outer join. To go from an inner join to a left outer join, all we have to do is put on that keyword left right there. That's it, nothing else. Okay, so back over here, I'm going to put on left join. We'll then run this. And then if we scroll all the way to the bottom of our result set, we'll see down here banner.jpg and the associated username is null. So we are seeing banner.jpg here because we are now doing a left join, which will include all rows from photos, even if there is not a matching user. Whenever we try to list out properties from the associated user with this image or this photo, we'll just see values of null. Okay, so that's a left outer join. Let's now try out a right outer join. So an example of a right outer join would be if we try to do something like list all users and their associated photos, and even list users who do not have a photo. Let's try to add in a brand new user to our users table, and this user will probably have no photos associated with them. We'll then try to do a right outer join, and you're going to see that even though this brand new user does not have any photos, we will still see them listed. Okay, I'm going to first delete this query, and we'll add in a little bit here to add in a brand new user. So I'll do an insert into users. We're going to specify only a username. We'll provide values of just Nicole. That's going to be our new username. So I'm going to run this. Looks like it was successful. And now we can do another join where we try to pull out the URL and the username. And we want to make sure that we select not only our photos, but every single user. So we'll do a select URL and username from photos. We will do a right join on users. I'll put in that on keyword, and then we will give our matching criteria. So we want to match up rows from users with rows from photos using the criteria users.id equals to photos.user_id. Okay, so let's now run this. Now we're going to see a very similar output to what we saw before, where we see all of our different user names with the associated photo URLs. But if we scroll all the way down to the bottom, we'll now see that we've got a user here with no photos associated with them at all. We've got Nicole, and the associated photo is null, or really the URL is null, because there is not a photo associated with Nicole at all. Okay, so that's a right outer join. And now finally, we'll take a look at a full join. So again, this is going to give us all of our different results, all the different rows in both tables, even if they do not actually match up. So at this point, we have banner.jpg with no matching person, and it's now really Nicole with no matching photo. So to do a full join, just one small change that keyword right there from right to full. We'll then run this. And now we'll see, okay, get all the same results. And if we scroll down to the bottom, here's Nicole. They have no matching photo. And here's a photo with no matching user. So a full join will give us all results, even if they don't match up on either side. All right, so that's just a couple of examples around each of these different kinds of joins. Now there are some more notes I want to give you around this stuff. So quick pause, and I'll talk to you in just a little bit for just a couple more things around these joins. A couple of videos ago, I showed you these notes, and I told you that the table order between from and join frequently makes a difference. So now that we understand these 4 different kinds of joins, let's really try to understand when changing the order of the from and join tables actually does or doesn't make a difference. All right, so here we go. we're going to take a look at the left outer join, where we only alternate. The only difference between these two queries is the order of tables we list in from and join. So on the left-hand side, we are taking rows from photos and joining in users. And then on the right-hand side over here, we are starting off with all the rows from users and joining in photos. And then again, we are doing in both cases a left outer join. So let's walk through this and understand the difference. We'll start off over here first. Now we've gone through this process a couple times now. So we would take all of our different rows from photos, because that is what is specified in that from statement right there. We would then merge in each of these different users using the user ID column. So we would take 2, and I know you've seen me do this many times, but believe me, just 1 or 2 more times. We'll take the 3, we'll take the 1, and then finally, because we are doing a left outer join, this row right here doesn't match up to any user, but because it is a left join, we are going to say that we want to keep that row, and we will give them some null user attributes like so. So when we listed out from photos and then left join users, so photos then users, we ended up with this extra photo right here. Let's now go through the same process. Still a left outer join, but we are swapping the order. We're saying from users, left join photos. Now in this case, we're going to start off with all the different rows from our users table, and then we're going to try to match up that user ID right there to the user ID column on photos. We're still doing the same comparison we were doing before. We are still trying to match up a photos user ID property to a users.id property. So still doing the same comparison. So we would take a look at user with ID 1 right here and find a photo corresponding over here. It looks like it's that right there. So I would pull that user down, pull down that one, and pull down that one. And now, once again, we have a user right here that has no matching photo to them. But because it is a left outer join, we are going to keep that row around. We are going to give them some dummy values for a photo. So we'd put in null and null and null. And now we are left with for Gerard Mitchell with no corresponding photo. Now take a look at these two result sets. On the left-hand side, when we list out photos first and we did a left outer join, we ended up with this photo right here that does not have a corresponding user. And when we swap the two and start off with users first, because this is still a left outer join, we ended up with a extra user down here who did not have a corresponding photo. So the answer is yes, there is a difference in the order in which we list these tables in the from and join statement whenever we use a left or right outer join. So left and right outer joins, we definitely want to keep in mind the order of these tables, we list them out, but with an inner join or a outer join, in general, it doesn't make a difference. Now, having said that, there still are some scenarios where you will want to kind of massage the order of your join when you're using an inner join or an outer join, especially if you are joining multiple tables together, which is something we will talk about later on inside the course. Okay, so that is it. That's a couple of notes on joins. We've taken a look at some notes on them in general, and we've seen these 4 different variations of them. And we're going to use these different variations to solve different kinds of queries. So let's get a little bit of practice in and really understand the difference between each of them. Let's take a look at a quick exercise. So our goal here is once again to work with authors and books. We want to write a query that's going to return the title of every single book along with the name of the author of that book. Now, very importantly, we want to make sure that all the different authors are included. So we should see every author in the result set, even if they don't have a book associated with them. We can then take a look at our data here. So we've got a table of authors. We definitely have 3 authors, and we've got 3 books. But if you look very carefully, you'll notice that the second 2 books on here are both associated with the author with ID 2. So right now, the author with ID 3 has no books associated with them. So you need to make sure that you write out a join that's going to include that 3rd author, even though they don't have any books. So go ahead and give this a shot. As usual, we'll take a look at a solution in just a moment. All right, my friends, let's take a look at a quick solution. So our goal here is to print out the name and title of everything We want to make sure that we get all the different books and all the different authors, even if an author does not have a book associated with them. Now we have a decision to make. We can either use a left outer join or a right outer join. Which join we use depends upon what our starting table is. In our case, we want all authors no matter what. So if we want to use a left outer join, we have to use a from authors to make sure we get all of our different authors. Again, you could follow this little purple diagram right here. So we would imagine that the purple in this case is authors. A left outer join will give us all the different authors. Alternatively, we could use a right outer join. If we do that, then our from right here would be photos, or excuse me, not photos in this case, but books. And then we would join in authors. And then in this case, authors would be on the right-hand side, and we would be getting all of our different authors, even if they don't match up to some particular book. Okay, so those are our two options here. I'm going to walk you through both solutions because it should be pretty easy to make a quick change. All right, so let's do first off a select statement. We're going to select the title and name of everything. We'll then start off with a from of authors. We definitely want to make sure we get all of our authors no matter what, so we will use a left outer join. We'll do a left join. And we're going to add in books on books.author_ID equal to authors.id. And that's pretty much it. Let's check our solution. And now when we see our results, they might look a little bit funny. That's just because for this last entry right here, we have an author name of J.K. Rowling, but a title of null. This table formatting on this little tool right here is just a little bit off. So the name right there really should be under the name column. It's just a formatting mistake that the table is kind of making it seem like J.K. Rowling is a title. It is not a title. It is just a formatting mistake. Okay, so that is a solution with left join. So now we can try an approach with right join. So with right join, we will first start with books, and then we're going to join in our table of authors. So from books, and then right join authors. Now we don't actually have to make any update to that comparison right there. The comparison order can go in any order we wish. So books author ID is totally fine, or we can flip it around if you want to, but it is totally fine as is. So I'm going to check my solution, and it looks like it is still correct. Awesome. Okay, so those are two possible solutions. Let's take a pause right here and continue in just a moment. We've been talking about joins for a while now, but unfortunately, joins are really important for you to understand, so we've got to talk about joins just a little bit more. In this video, we're going to start to take a look at some variations on joins that are going to use some other important SQL keywords. All right, so we're going to focus on trying to answer the following question. This is our task. Users can comment on photos that they posted. No issues with that whatsoever. I want to try to list out the URL and the contents for every photo and comment where this occurred. So in other words, I want to figure out who is commenting on their own photos. Or more specifically, I just want to print out the URL and contents wherever a photo was commented on by its creator. So we're not printing out any information around the user right now, just some information from a photo and a comment. So we can solve this very easily by using a join and one other SQL keyword that we actually took a look at a little bit ago inside this course. Let's first imagine this joining action first, and then start to understand how we can make sure that we only print out information when it is a comment that was posted on a photo that a user posted. All right, so first, just the join stuff. We're going to do an inner join on comments with photos. So we've been through this process so many times, and I've even said that many times. So we'll bring down all these rows, and then for every photo ID, we'll do a lookup into photos and try to find the appropriate photo. It looks like first we've got a photo ID of 2. So we'd put that right there. Next up, a photo ID of 3. We'd put that right there. And then a photo ID of 1. So we'd put that right there. So there's our join. And now we could very easily print out the contents and the URL for this entire join table. But that's not quite what we want. We only want to print out the contents and the URL where the person who created the comment is also the person who created the photo. So to do that, we could find only the rows where the user ID of the comment is equal to the user ID of the photo. If these two values, user ID and user ID, are equal to each other, that means that the same user created the comment and they also created the photo. So in this case, it looks like the only case where that is true, where we've got a equal user ID, is on the middle one right here. It looks like the user with ID 5 created both that comment and that photo. So we would want to somehow filter out those other rows, and we would only be left with the middle one. All right, so I use the term filter out. You might recall that we spoke about the where keyword earlier on inside this course. We can use the where keyword to somehow filter out rows. We can also use the where keyword on the results of a join statement, like this kind of imaginary table that we have right here. So with that in mind, let's try to write out a query that's going to solve this little question right here. All right, so let's give this a shot. Over here, I'm going to first select the two columns that I know that we need, which are going to be the URL and contents. We're then going to start off with all the rows from our comments table, and we're going to join with our photos table. We'll then make sure that we specify how to merge these two tables together by putting in that on section. So we'll say on photos.id equals to comments.photo_id. So at this point, let's just put a semicolon in here, run this, and make sure that we see some data that looks realistic and that the query works. Okay, I'd say this all looks reasonable. Now we're going to add in a where statement that's going to somehow filter out some of these rows. I'm going to delete that semicolon on the very end. And then after the join, we will put in our where. So a where is always going to go on the other side of a join. I would never expect to see a from, and then a where, and then a join. It's always going to be from, join, where. And then inside of here, we can write some filtering criteria. Now, how are we going to make sure that we only select rows where the user ID is equal to the user ID? Well, remember, anywhere inside this query, we can refer to the comments table and the photos table. So we can say, take a look at the comments table. More specifically, look at its user ID column. We only want to find rows where comments.userid are equal to photos.user_ID. So this comparison right here is doing exactly what we just saw inside that diagram. We're just literally looking at these two rows, or these two columns. We're comparing the value in each of them and saying if they're equal, we will keep them inside of our result set. Otherwise, if these two values are not equal to each other, then toss them out. Now, this is another scenario where you really need to remember that comparisons like this are being done for every row inside of this imaginary table right here. So every single row gets that comparison done. We start off with the first row right here. We check to see if user ID is equal to user ID. If it is not, we'll toss it. How about this one? Oh, they're the same. We'll keep it. How about this one? They're not the same. We'll dump it. Okay, so let's now run this. And now in theory, we are seeing the URL and the contents where in each of these cases, and again, this is like kind of hard to say in English, but basically these are all comments and photos where the author of the photo is also the author of the comment. So this would all be information where some kind of user commented on their own photo. All right, so that is pretty simple. Maybe not, I don't know. But we've seen the use of the where keyword inside of a join. Now, I want to do something a little bit more complicated. This is going to sound like it might be something that's kind of easy, but unfortunately, yeah, it's not the easiest thing in the world. We are only showing information about the photo and the comment now, but we don't actually know which users, per se, are actually posting on their own photos. It would be really nice if we could somehow print out the username of each of these different users. But at this point in time, in our results set, we have no information about any users whatsoever. So we're going to have to do a little bit of thinking here to figure out how we can somehow get the username of the person who posted on their own photo. Let's take a look at that in the next video. As I mentioned in the last video, we currently have no information about the user who actually posted on their own photos. At no point in time did we ever actually access the user's table, so we cannot print out their username. So let's try to fix that. We're going to alter this query so that we not only post out the URL of the photo, the contents of the comment, but I also want to get in here the username of the person who actually posted on their own photo. To do this, we're going to have to use a little bit of an advanced technique around joins. So let's walk through a diagram really quickly and understand what is going on first, and then we'll start to write out a little bit of SQL. All right, so here's the idea. We are going to do a three-way join. A three-way join is where we merge together three different tables. Now, conceptually, this is definitely very challenging, but the actual SQL for it ends up being very simple and straightforward. But again, conceptually, very hard to understand. So in this case, we need information from comments and photos and users. We have to pull values from each of these. And that means that we need to join them all together into the same temporary table. So down here, I once again have this imaginary fake table, and it has columns from all three different tables. Here's the set of columns right here from comments. We've then got the 2 or 3 from photos, and then the 2 from users right there. So we can first get started by selecting all the different rows inside of comments, and then we'll put them into this imaginary table. We can then join on photos. And as usual, we'll go through and take a look at the photo ID and make sure it matches up with a ID out of the photos table. So we start off first with photo ID 2, throw it down, photo ID 3, and photo ID 1. Okay, so that's how far we've gotten at this point in all of the past videos. We have gotten this far, no problem whatsoever. So now we are saying that we want to somehow merge in this third table. Merging in this third table is going to require us to really think about the merge condition, or essentially the comparison that we are putting right here on that on section. If we just put in something like comments.userid equal to users, so in other words, if we just try to match up this column right here to this column right here, that will not necessarily give us users who posted on their own photo. Let's think about what condition we are really trying to check for. What we really want to see is when this user ID right here is equal to that user ID right there and equal to some ID inside of this table. That's what we are really looking for. We want to see where this ID, and some row out of this table are all equal to each other. So in the first case, we have a user ID of 2 right here for the comment, and then a user ID of 3 for the photo. There's going to be no user, or there is no user who created both the comment and the photo because these IDs are different. And so we can really imagine that right here for this first row, we would get null and null. Now, when I say we would get, I just mean to say like logically, not even worrying about SQL or anything like that, there is no user who satisfies the condition of having an ID equal to this user ID and that user ID. So there's no value we could put inside there because no user can satisfy this condition. But on the next row, we want to try to find a user with an ID equal to that value and that value. Is there one? Well, yeah, here they are right here. So this is a user that satisfies both of those constraints. This user has an ID equal to that value and that value. So now we would say that Frederick Donnelly created the photo of whatever that URL is right there, and then they created a comment with that contents on their own photo. Now we can repeat this process for the third row. In this case, we are looking for a user with an ID equal to 3 and a user with an ID equal to 2. Well, once again, there is no user who can satisfy that. There's no user who has an ID of 3 and 2. And so again, we would end up with null values right there. So now at this point in time, if we just printed out this table as is, we would end up with some values in here that say null. And we don't really want those values. We only want to see comments and photos where the user posted the comment and the photo. So we could try to either do some kind of where expression, some kind of where check, where we'd say, yeah, don't show us any user names or any rows where the username is equal to null. Or alternatively, remember, we just took a look at those 4 different kinds of joins, and we spoke about how an inner join is only going to show us rows where there is a matching value from all tables involved. So if we did this 3-way join with an inner join, then these rows where there's no matching user would essentially fall out, and we are left with just this one row right here. Okay, so that is the theory. That is what we essentially want to implement. So let's now go over to our editor. We're going to make a real small change to the query we've already got inside there. And we're going to see that, well, writing out the SQL for a three-way join is really simple, but again, understanding it is a lot more challenging. Okay, so back over here, we still have select URL and contents, but now we also want to get the username. We're going to take all the rows from comments. We're going to join photos, and we want to find or somehow merge these two tables together by finding where the photos ID is equal to comments.photoid. So that's what got us to kind of like stage one right here, where we just had this first set of columns. And now we want to add in the users table as well. For that, right after the first join, we can add in another join. So on this additional join, we're going to add in users on, and then this part right here, the merge criteria, this is the important part. So we want to somehow merge these users in, and our criteria for this is to find where the user's ID is equal to the comment user ID, and the user ID is equal to the photo user ID. So we would write this out with an AND expression. We would write out users.id equal to comments.userID. That's going to make sure that we find a user with an ID equal to the comments user ID, and users.id is equal to the photos.user ID. And that should do it. So the entire key here is that we are trying to find users or merge these things all together where the user's ID is equal to the comment ID and the user's ID is equal to the photos user ID at the same time. That's going to make sure that all three of these different values, user's ID, comments user ID, and photos user ID, are equal to each other. Okay, so let's now run this, and it looks like it worked. Now in theory, these are all photos and comments where the author of the photo and the comment is that person right there. If you want to, you could do a select star from comments, select star from photos, and select star from users, and compare the IDs of each of these different records and just make sure that they actually do match up to each other. But I'll leave that up to you. All right, so this has been a rather advanced use of a join statement. It is a three-way join because we are joining together three different tables. And the key thing to keep in mind here is that whenever we do a three-way join, usually that second join, this one right here, is going to have a little bit more complicated merging expression because we need to really think about, well, what values or what rows go with whichever rows. Okay, so let's take a quick pause right here and continue in just a moment. Let's take a look at a quick exercise just to make sure the idea of a three-way join is crystal clear. We're going to try to solve a problem very, very similar to the one that we just went through in the last video. So we are again working with a table of authors and books, and now we've got a new table inside of here, a table of reviews. Reviews has a couple of columns inside of it. It's got an ID, of course, and then a rating. The rating is the rating of a book on a scale from 1 to 5. So a 5 would mean that a book was very good, and a rating of 1 would mean that maybe the book is not so great. There's then a reviewer ID inside of here. The reviewer ID column stores the author or the ID of the author who created the review. So this first review right here has a reviewer ID of 1. That means that the first review was created by Stephen King. The next review was created by an author with an ID of 2. That means the second one was created by Agatha Christie, and then as you can guess, last one is J.K. Rowling. And then finally, the third column is the ID of the book that the review is for. So for example, the first review was a review for the book Affair at Styles. Okay, so we've got these three tables, and now here is our goal. We're going to return the title of each book, along with the name of the author and the rating of a review. But here's the critical part. We only want to show rows where the author of the book is also the author of the review. That is our join criteria right there. That is the critical part. So just to make sure that what we're doing here is very clear, let's walk through this in diagram format very quickly. So I'm going to again do a three-way join here because I want to get information from all three tables. If we did not need information from all three tables, we could potentially just do one join and then maybe use a where statement instead. We're going to first start off with our reviews as the from table. So we're going to take all the different reviews, and as usual, we can imagine that we put them into this very temporary table. We'll then join in books. And when we join this in, we're going to take a look at every one of our reviews. We're going to take a look at the book ID column and try to match it up, the value inside there, to one of the rows inside of books. So we've got a book ID of 2. That would match up with a ferret styles. So we put that right there. We've got a book ID of 1. That would match up with the dark tower. And then finally, a book with ID 3. That would match up with Chamber of Secrets. Okay, so there is reviews and books. That's a normal join. We have gone through this process many times. Now here is the three-way join. We're now going to merge in authors. So with authors, here's the hard part, the part that we really got to think about for a little bit. We want to somehow use the following join criteria. We want to put in a value right here where the row out of the authors table has an ID equal to the reviewer ID, and that same author has an ID equal to that same row's author ID. So in other words, we want to do a comparison between reviewer ID and author ID and ID. In this case, there is no author who has an ID of 1 and simultaneously an ID of 2. There's no author in this table who has an ID of 1 and 2 at the same time. It just doesn't exist. So we would end up with, right here, null and null. So then on the next one, we've got a reviewer ID of 2 and an author ID of 1. We need to find an author who has an ID of 2 and 1 at the same time. Well, once again, doesn't exist. So we would end up with null and null. And then finally, on the very last one right here, we want to find an author with an ID of 3 and an ID of 3. Well, in this case, yep, it does exist. It is J.K. Rowling. So J.K. Rowling would end up right there. So this would be our full join table. All three tables joined together. And then finally, we would probably want to do an inner join here. If we did an inner join, then any of these rows that ended up not being able to be matched up would be dropped out. So we would drop out 1 and 2 like so. And that would leave us with just J.K. Rowling, who I guess left a review for her own book. It's okay. They were good books anyhow. All right, so that's the idea. Go ahead and give this a shot. Again, the actual query you're going to write is going to look very similar to the one that we just wrote in the last video. So if you need any reference, you can always go back to the last video and just take a look at how that one was written. Go ahead and give this a shot, and I'll see you in just a minute. All right, my friends, let's take a look at a solution to this exercise. I'm going to first get started by selecting the different columns that I know that we're going to need. So I'm going to select title, name, and rating. Select title, name, and rating. I'll then specify the starting set of rows that we're going to work from by using the from keyword. So that's going to be from reviews down here. I'm then going to join in the books table. When we join in the books table, we want to join these two tables together by finding where one of the reviews book ID value is equal to the ID value inside of books. So we're going to join in books on books.id equal to reviews.bookid. Now at this point in time, we've got a normal join. Now we need to join in our third table. So we're going to join in authors on, and this comparison right here, what we're going to type right here, this is where things get really complicated. So we really have to think through and really understand the structure of our data. So we want to find where, firstly, the author's ID is equal to the author ID of a book. That's going to be how we make sure that we join together authors and books correctly. So we're going to take a look at authors.id equal to books.authorID. And then simultaneously, we're also going to merge together authors ID with a review's reviewer ID. That's going to be what makes sure that we join together reviews and authors correctly. So I'm going to put down the first comparison right there, and then authors.id equal to reviews.reviewer ID. And that's it. Because we are doing a inner join here, if there are any rows that have null values inside them after the merge, they will be dropped out. And we should be left with only the rows where we have a essentially value in every set of tables. So the set of columns every set of columns, not set of tables. So every set of columns for authors, books, and reviews. Okay, so let's check our solution and see how we're doing. Awesome. Looks like we got it. So Chamber of Secrets, J.K. Rowling, rating of 5. Looks like she definitely left herself a review. Okay, I know this has been challenging. This is pretty much as bad as join statements get when you are first learning about them. So if you found this challenging, I totally expect it, 100%. If you found this easy, well, fantastic. It means that you're coming along very well. At any rate, let's take a pause right here and move on in just a moment. With all the queries we've worked through in this course so far, we've always been trying to pull out, well, just a set of rows, essentially the exact information more or less that we threw into the database. Moving forward, however, as we continue to look at some more complicated queries, we're going to introduce 2 additional techniques. One is called grouping, the other is called aggregates or aggregation. The goal with these 2 techniques is to take a big set of values or a big set of rows and somehow condense them down to a smaller set of values. With grouping in particular, we're going to take many rows. So we're going to write a query that's going to select or somehow obtain many different rows. And then we're going to somehow group those rows to some fewer or lesser number of rows. So the result of grouping is rows. We execute grouping by using the group by SQL keyword. When you first get started with grouping, it's really kind of challenging to tackle when you first get started, particularly as you start to select data or select columns out of the grouped information. To avoid those challenges, the best thing to do is to really visualize what happens when you apply the group by keyword. As long as you kind of get a mental picture in your head of what group by does, life starts to get really easy. So as we start this grouping by stuff, we're going to take a look at a lot of different diagrams to really understand what it does for us. Okay, so the other thing we're going to talk about is aggregates. The goal of an aggregate is to take many different values and reduce them down to one value. So when I use the term values here, I'm really talking about distinct values inside of a column of data. So we might take many rows, we might select one column out of all those different rows, and then apply an aggregate function to them. It's going to take all those different values in those different columns and condense it down to one single value. We apply aggregates or create aggregations by using an aggregate function. All right, so honestly, we could lecture about these things all day, but it makes a lot more sense to just write some code and play around with them a little bit. Let's pause right here and then start learning about grouping and aggregations in our sample dataset. In this video, we're going to take a look at the grouping technique. Remember, grouping is all about taking many rows and condensing them down to some fewer number of rows. The best way to understand grouping is to really just write out a query or two. So let's get started by writing a query. Back over here, we're going to put in select user ID from comments, and then we will say group by user underscore ID. I'm then going to run this. And as a quick note here, notice how group by is 2 separate words. Group by is always going to be 2 separate words. Then we can see the result, which is just a user ID column of 1, 2, 3, 4, and 5. So we only got 5 rows back here. But remember, overall, we've got about 100 different comments. So what's really going on? Well, as usual, let's take a look at a very quick diagram. Okay. The best way to understand the group by keyword is, like I said just a moment ago, to really visualize what is happening. So whenever we use group by, in this case, group by user ID, here's what's going on behind the scenes. Your database is going to take a look at all the rows that you have selected at this point. Inside of our query, we have selected all the rows from the comments table. Your database is going to go through all those different rows. It's going to find the user ID column, and it's going to try to find all the unique values inside that column. If you look at the values inside this column right here, the unique values are 1, 2, 3, and 5. Those are the only values that occur inside this column. There's no 4s. After finding all the different unique user IDs, your database is then going to take each of these different rows and assign it to a different group based upon that row's user ID. Now, once again, just stating this stuff in text, not super helpful. So again, let's look at a bigger diagram to really picture this entire process. Okay, so over here on the right-hand side, we're going to imagine that this is where the grouping is taking place. We once again, very similar to all that join stuff, can kind of imagine that we are getting a very temporary imaginary table created inside the database. When we say group by user ID, that's going to create a new grouped column inside of this imaginary database. Inside this column, we're going to place all the unique values from user ID. So we can kind of imagine that this is what happens. We can kind of imagine that we get a number of rows inside of here, and each one is going to contain a unique user ID from the table. That'd be 1, 2, 3, 4, and 5. Technically, 4 is not actually in that table, so it actually would not appear in here at all. And we would end up with just 1, 2, 3, and 5. Your database is then going to take each of these individual rows and assign them to one of these big groups over here. So we can really imagine that we're going to go row by row right here. We're going to take a look at the user ID. In this case, it's 1. So we would assign it to the group user ID 1. The next one has a user ID 3, so it'd be placed right here. We got a 5. We've got a 3, a 2, a 2, and a 1. So now on this process table, notice how all the values inside the user ID column all match up to each other in their respective groups. So group for user ID number 1 has only rows that have a user ID value of 1. Same with 2, same with 3, and same with 5. So we can now try to select information out of this new temporary group table. But there is a big catch on what we can select. We can only select some very certain columns. We can only select in particular the grouped column. We are not allowed to directly select any of the red columns or the underlying columns inside of our original table. Let's try selecting one of those right now back over inside this query. We could add on select about just contents. And if we do that, we'll get a big error that says, hey, sorry, but you can't do that. If you want to select contents, it must appear in the group by clause, or you have to use it in an aggregate function. So we can only directly select the grouped column. If we want to, in any way, work with these underlying columns, we can only select them by using an aggregate function, which is something that we mentioned just a moment ago. Just the fact about aggregate functions existing. So this is the really important thing to keep in mind, is that you really want to visualize what your data looks like after it gets grouped. And you just have to remember that you can only directly select the grouped column. I can't tell you the number of errors that you might run into in the future because you try to select one of these subcolumns, like ID, contents, or user ID, and again, you're going to end up with an error like what you see right here. Okay, so at this point in time, our example of grouping by user ID isn't super useful until we also introduce another topic, which is those aggregate functions. So let's take a look at aggregate functions in the next video, and then we're going to kind of mash together the idea of grouping records and aggregate functions, and then we're going to be able to run some really interesting queries. Let's take a look at some different aggregates. The goal of an aggregate is to reduce many different values down into just one. We create an aggregate by using an aggregate function. Here's some of the different aggregate functions that we're going to make use of. So we can use these functions to get the number of values inside of a group of values. We can sum a bunch of numbers together. We can find the average, the minimum, and the maximum. As usual, the best way to understand this stuff is to write out a little bit of SQL and just execute it. So I'm going to go back over to my editor, and I'm going to write in a query here that is going to select the maximum value out of the ID column from comments. So I want to find the comment with the largest ID. I'm going to run that, and I get back 100, which makes sense because we've got about 100 comments or so. We can also find the minimum ID, run that, and we get 1. We can find the average ID, which would be around 50, 50.5. We can do a count, which will tell us how many IDs we have. And then finally, we can sum them all together, which will probably just give us a really large value. Yeah, there we go. So the one thing you'll notice around all these different aggregate functions is that we are taking a big column of values here. So ID has many values inside of it, and we are doing some kind of calculation or math operation on all those different values and returning just one single value. When we make use of an aggregate function, we cannot do a normal select next to it. So for example, I cannot sum ID and also just select ID at the same time. If I do so, I'll end up with an error message like so. We're going to most frequently use these aggregate functions by themselves or as a part of a larger group by statement, which is why we're talking about group by and aggregate functions at the same time. Now, just to make sure this stuff is super clear, just a quick diagram here. So we can imagine that maybe we wanted to find the maximum value out of the photo ID column on the comments table. So for that, we could do a max on photo ID, and it would give us the maximum number value out of there, which in this case on this diagram would be 5. If we did a minimum, the minimum value would be a 4. The average would probably be about, 4.9, and so on. You get the idea. So these different aggregate functions operate on a bunch of different values and give us back one single value. And again, we can only use them without doing a select on the same line. We cannot select a column and use an aggregate at the same time, or we end up with an error like so. Okay, so aggregate functions, I don't know, doesn't seem like the worst thing in the world. Let's take a pause right here. We'll come back in the next video, and that's where we're going to start to see some more interesting things, specifically mixing together group bys and aggregate functions. Let's now take a look at combining aggregates and grouping together. And as I mentioned, this is where we start to be able to do some really interesting things. All right, so to get started, I want to write out another group by query. We're going to do the same one we did before, where we group all of our comments by user ID. So we had previously select user ID from comments, and then we grouped everything by user ID, like so. And if we ran that, we saw just 1, 2, 3, 4, 5. Not really in order, but you get the idea. So after we ran that query, we then took a look at a diagram that looked like this right here. So remember, whenever we do group by, we're going to take all the rows out of some table, in this case, comments. We're going to find all the unique values inside of user ID. Your database is then going to set up an imaginary fake table where the only rows inside of it are those unique values. Your database then takes all the original rows from the comments table and assigns them to one of these different sets. So now that we've got this grouping done, we can now introduce aggregate functions on top of it. An aggregate function, if we use it while doing group by, is only going to be applied to each of these individual little subgroups. So for example, if we add in a max of ID as a new column, the ID or the maximum ID would be the maximum ID out of all of the rows just inside of this group right here. So in this case, the maximum ID between these two rows is 7. We would end up with a 7. Down here, the maximum is 6. So we'd end up with a 6. Down here is a 4, and then a 3. Once we use an aggregate function over these groups, we can then select that value like we do any other grouped column. So again, remember, whenever we do grouping, we cannot select the underlying columns, all the ones in red. We can only select grouped columns or the result of some aggregate function. Okay, so let's go back over to our editor and try to find the maximum value of the ID for all the different user IDs. So back over here, after user ID, I'll then put in max ID. So that's going to take a look at all of our comments. It's going to group them by user ID, and then we're going to see the maximum ID value for each user ID. So if I run that, we then get that second column. So it looks like user with ID 1, the largest ID they have tied to them is 79. User 3, the largest ID they have tied to them is 100, and so on. Now doing something like this is not super useful. Finding the maximum ID value, well, IDs are identifiers. They don't really have a numeric value per se. Adding them, subtracting them, dividing them, finding the minimum or the max, not really a lot of use to it. However, there are some other aggregate functions that start to making these things way more interesting, such as count. Let's take a look at what count would do in this scenario. So back over here, if we did a count on ID, this would return the number of IDs that we have in each of these subgroups. So we would get a 2, a 2, a 2, and a 1. Now, if we count up the number of comments that have a user ID of 1, think about what that really tells us. It tells us the number of comments that this user has created, the number of comments that user with ID 1 has made. And that's really useful information. It can help us understand the number of total comments that any user has made, which is something that just about all, say, forum software wants to display. Just about every forum that's ever been created, if you ever look at a user's profile, it'll tell you the number of comments or maybe posts that a user has made. So being able to do a count on a group by is really interesting and very useful. So let's try updating this. We're going to do a select user ID and count of ID. Now, if we run that, it's going to print up the number of comments that each of our different users have created. It looks like user with ID 1 has made 23, user with 2 has made 18, and so on. We might rename this column right here to something like as num comments created. And now that's some meaningful result right there. Any other engineer can really look at this and understand what's going on pretty quickly. Okay, so as soon as we start to introduce the idea of group by with aggregates, a lot of doors really start to open. Let's take a pause right here. We're going to take a look at a couple of corner cases and just some notes you need to be aware of in the next video. In this video, I want to tell you about a very big corner case around this count aggregate function. So I'm going to delete the query that we have for right now, and I'm going to replace it with a select star from photos. I'm then going to run this. We're going to take a look at a list of all the different photos we have. Remember, there's about 20 photos or so. At some point in time in the previous videos, we also added in an extra photo right here. So it looks like we have 21 photos in total. And I just want to remind you that the last photo that we added in does not have a user ID associated with it. It has a null value right there. Now, let's try something really interesting. I want to count up the number of photos we have. We're not going to worry about doing any group by. We're just going to do an aggregate function by itself. So I'm going to do a select count user ID from photos. I'm then going to run that, and you'll notice that we got 20 here, even though we just saw that there were 21 photos inside of our photos table. So what's going on? Well, whenever we do a count on a column, null values are not counted. So that 21st photo has a user ID of null. That does not increment our value. So we don't count that inside this count user ID. To get around that, because usually you're going to want to include all photos when you're trying to find a count, rather than referencing any particular column, you can instead put in count star, like so. And that means just count up the total number of rows. Don't look at any particular column, just count the number of rows. So if we run this, we now see the correct 21. Now we can go back and update the query that we were looking at just a moment ago, where we had select user ID, count star from comments, and then once again we can group by user ID. And so if we run that, we get probably the same result as we did before. I can't recall if we had any comments with a null user ID. You could always double check that on your own if you want to. But in general, whenever we make use of count, we're going to use star instead of referencing any particular column. Again, just so we can safely deal with this problem of possibly having null values. Now, there might be some scenarios where you do not want to count null values, but that's really up to you to decide how you want to deal with that or the specific problem you're working on. All right, so just a little corner case around count that you need to be aware of. Let's take a pause here and then start doing some more practice around group by and these aggregate functions in the next video. Let's take a look at another example of group by with aggregate functions. So in this example, we're going to try to find the number of comments for each individual photo. And before we even worry about group by or anything like that, we really need to consider our data source. What tables do we have to try to access here in this case? Well, in this case, all the information we need is on the comments table alone. We don't need to do any joins or anything like that. The reason that all the relevant information is on comments is because comments has the photo ID column inside of it. So here's what I think we could probably do. Here's our comments table on the left-hand side. We probably want to group by photo ID. That's going to group all of our photos together into individual little buckets. We can then run some kind of aggregate function on each individual bucket to count up the number of photos. So I'm going to do a group by. We'll say grouped with photo ID. Those are our buckets. And very much like user ID, it looks like the photo IDs in this case span from 1 through 5. So I could imagine that the unique values here that we're going to group by are 1, 2, 3, 4, and 5. So it then goes through and assign each of my different rows to one of these different buckets. We've got 5, 1, 4, a 2, another 4, a 3, and a 1. So now for each of these individual buckets, we would want to do a count star. And that will tell us the number of rows we have in this particular bucket. So in this case, we'd get 2, and then we'd have a 1, another 1, a 1 down here, and a 2 right there. So for this diagram at least, this is what I would expect to see. I would expect to see each of the photo IDs with a 2, 1, 1, 2, 1. Of course, our actual database has some different information inside of it, but that's kind of the structure of data I would expect. So let's now go write out a query that's going to implement this entire process. Okay, so back over here, we will do a select photo ID and a count star from comments. We'll then group by the photo ID. And that's it. So build up all those different buckets, print out the bucket label, and then count up the number of rows in each bucket. So let's go ahead and run this. And there we go. So you'll notice that only our first 5 photos have comments attached to them. All the other comments inside of all the other photos inside of our photos table don't have any comments assigned whatsoever. There are 20 photos overall, only 5 of them actually have comments. Okay, so that looks pretty good. So we've now seen 1 or 2 simple examples of aggregate functions and grouping. Let's go through another exercise in the next video. Time for a quick exercise. So we're again working with books and authors. Our goal here is to write a query that's going to print out an author's ID and the number of books that they have authored. So we've got a table of authors and a table of books right here. Now there's a little hint on here. Even though you have an author's table, I'm not really sure you're going to need to use it. I think that all the information you need to answer this query exists inside of the books table alone. So chances are, whatever solution you come up with, probably not going to need to touch the author's table at all, probably only needs to work with books. So go ahead and give this a shot. As usual, we'll go over a solution together in the next video. All right, let's go through a solution together. Now, one thing that's kind of awkward is when you try to write out the entire select statement before you put any group by stuff together, because the group by logic is really going to explain the different columns you have available to select. So I'm going to put in the select keyword, but I'm going to put out my from and my group by first. I'll then come back to select after that and fill it in. So my source of information, or the source of rows here, will be the books table. I definitely then want to do a group by on there to group by the author ID. That should give us a new imaginary table where we have different buckets for the author with ID 1, 2, 3, and 4. So I'm going to group by author ID like so. Now we can go back to select and start putting some logic inside there. First off, the directions say that we had to print out the author's ID. So I'm going to select author ID. And then we want to count the number of rows associated with this user in each of these grouped buckets. So very similar to what we saw just a moment ago in all those examples, we'll put in a count star. All right, so let's check our solution. See how we're doing. Yep, looks like it worked out just fine. All right, well, this was a simple example, but let's take a pause right here and go through a more challenging one in just a moment. One more quick exercise around grouping and aggregate functions. This exercise is identical to the last one that you just solved, but it has one extra little challenge on top. As you can kind of guess from the title here, this time around, we want to pull some information from both the books table and from the authors table. In particular, we want to print out the number of books that each author has authored, but we want to make sure that this time we use the author's name instead of just the author's ID. So we're going to have to somehow join together or merge together these two different tables, then do a group by and print some information out. So go ahead and give this a shot. We'll go over a solution in just a moment. All right, let's take a look at a solution. Now, I said in the exercise here that this thing is very similar to the last one, but there is a very small difference. This time around, we want to print out the author's name. Because we want to access that name, it means we have to do a group by using the author's name. Because remember, if we don't include a column in the group by, then we cannot access it inside of our select statement. So let's try to put together a solution. We're going to do a select from books. We're going to join authors on authors.id equal to books.author.id. Then we'll do our group by. We'll group by the authors.name. Alternatively, we can just write out name by itself here. We would only put in authors just to be a little bit more clear on where the name column is coming from. So now that we have referred to or done some grouping by the author's name, we can now refer to that column inside of our select statement. So up here we can do name, or again, we can do authors.name if you want to make things just a little bit more clear. And then we'll also do a count star to see how many rows got put into the name bucket. All right, let's go ahead and give this a shot. So I'm going to hit check solution. And it looks like we are good to go. All right, fantastic. Well, let's take a pause here and continue on in just a moment. At this point in time, we've taken a look at a couple of different keywords, and we can really start to remember that all these different keywords are always going to appear in a very specific order. So we've got from, join, where, and then group by. In this video, we're going to start to take a look at a new keyword called having. Having is very similar to where. Its goal is to filter out some amount of information. The difference between where and having, however, is that where is going to operate on filtering out some number of rows, whereas having is going to filter out some number of groups. You are never going to see having without a group by. So you will always have a group by right before a having. You don't have to have a having if you have a group by, but if you want to do any filtering on the groups, you will make use of having. All right, so let's take a look at a very practical example and understand where to use having. All right, so let's try to solve a little query here. We're going to walk through it in kind of diagram format and then write out a query to solve it. Our goal is to find the number of comments for each photo, where the photo ID of the comment is less than 3, and the photo has more than 2 comments. That's our goal. Now, I want you to notice right away that there are 2 filter conditions here. The first one is we want to filter and only take a look at comments where the photo ID is less than 3. The second filter criteria is to make sure that the photo has more than 2 comments. The first filter criteria that we're taking a look at here, this sentence right here, we're saying the photo ID is less than 3, that is concerned with the value inside of a particular row. So because we are talking about doing some filter operation over some number of rows, we're going to be making use of the where keyword for this filter step. The second filter step right here is talking about some kind of aggregate function. We have to use probably the count aggregate function to find the count of number of photos tied to a comment. And so for that, we need, or excuse me, the number of comments tied to a photo. Anytime that we're talking about using some filtering along with an aggregate function, that is when we want to use having. So again, having, whenever you see it, it's going to be very close to a group by, and chances are having is going to have an aggregate keyword inside of it, or an aggregate function. All right, so let's imagine what this is going to look like. The first thing we're probably going to want to do here is do a kind of where step, where we will filter out some number of rows. So this is going to try to enforce the first filter criteria right here. We don't want to see any comments where the photo ID is less than 3. So I'm going to find all the records where the photo ID is less than 3 or is greater than 3, equal to or greater than 3, and I'm going to delete them right away. So this one has a 4, I'll delete that. There's a 4, and there's a 3. So that would be our where step. We have filtered down the initial number of rows that we are working with. So now we would do a grouping step. We would try to group all these records together by photo ID. Well, it looks like we've got photo IDs of 1 and 2. So I would end up with a group 1 and 2. I would then assign all these records to one of these different groups. So I would put that one right there because it's got a photo ID of 1. Got a photo ID of 1 and a photo ID of 1. And then the last remaining one right here has a photo ID of 2. So I'd put it right there. Okay, so now we can imagine that we would go through the count operation, where we would count all the different rows in each of these different groups. So in the first group, we definitely have 3 records. In the second one, we have just 1. So now this is the part where we would execute that having phase, or that kind of having keyword. So now we would want to go through each of these groups and somehow filter out each group based upon the results of one of the aggregate functions, in this case count. So we only want to find groups where the photo has more than 2 comments. Well, in this case, it looks like the second photo ID right here only has one comment. So we would imagine that we would delete that one, just remove it from our results set entirely. And now we are left with just this first group right here. All right, so the entire idea here, just to repeat once again, we make use of where to filter out the initial set of rows. We then apply our grouping logic, and then we will add some additional filtering using having. And inside of a having statement, we are almost always going to be making use of an aggregate function. All right, so now that we've got a vague idea of what's going on here, let's take a look at one or two actual queries in the next video. All right, let's try to now solve this query with some actual SQL. So we're going to find the number of comments for each photo where the photo ID is less than 3 and the photo has more than 2 comments. So back over here, we will do a select, and I'll get the photo ID and count star. That's going to give me the photo ID, of course, or the ID of the photo, and then the number of comments associated with that photo. Next up, we're going to start from comments. So we're going to take all the different rows of comments. We're then going to apply some initial filtering logic. So out of all the rows we have inside of our comments table, we only want to take a look at the comments where the photo ID is less than 3. So to filter out that initial set of rows, we will make use of the where keyword. We will say where photo ID is less than 3. Then after that, we're going to apply our grouping logic. We want to attempt to group all the remaining rows by their photo IDs. So once again, our database is going to take a look at all the unique values inside the photo ID column and set up some different groups and then assign each row to one of these different groups. So for that, we'll put in a group by photo ID. And now that we've created these groups, we want to filter out some number of them. And we're going to do that filtering by using the having keyword. And once again, anytime you see having, chances are you're going to see an aggregate function used inside of it. So in this case, we only want to take a look at groups where the photo has more than 2 comments. So we're going to count up all the different rows inside of each of these groups by doing a count star. So we'll do a count star. And then we only want to find the photos that have more than 2 comments. So we'll do a count star greater than 2, like so. So that's it. That would be our solution. So once again, just one more time, I know this is something I repeated 3 times. Where is for filtering out individual rows. We then apply the grouping, and then we make use of having to filter out some number of those groups. Let's run this and see how we're doing. All right, there we go. So we are now seeing all the different photos, or all the different comments, or I should say the number of comments per photo. That's the real phrase I'm going for there, where the photo ID is less than 3 and the photo has more than 2 comments. All right, well, this looks pretty good. Let's take a look at another example of having in the next video. Let's take a look at another query. So this time around, we're going to try to find all the users, or specifically the user IDs. I'll put that on here, where the user has commented on the first 2 photos. So that would be a photo with the ID of 1 or 2. And the user has added more than 2 comments on those photos. So this is a little bit tricky one. But again, we can once again see that we have 2 different filtering criteria. The first one, we're going to make sure that we kind of filter out the initial set of rows. We only want to take a look at comments, in this case, where they were added to the first 2 photos, or a photo with ID of 1 or an ID of 2. That is an initial filter on our first set of rows here. Then the second filter we want to add is definitely talking about adding in some kind of counting functionality. We got to take a look and find users where they added more than 2 comments. So we need to count up the number of comments. Because we need to do a counting and then a filtering operation, that is a sign that we need to do a group by and then a having using an aggregate function. So once again, let's walk through this in diagram format and then actually write out the query. Okay, so to get started, we want to apply the initial filtering criteria here. We only want to find comments that were added to the first 2 photos. So we're definitely going to be working off the comments table. We only want to find comments where the photo ID is 1 or 2. So I would delete this row right here because it has a photo ID of 3. I would delete that one and that one. And now I'm left with only rows where they are comments added to photos with an ID less than 2. Or I guess I should say here less than 3. Less than or equal to 2. All right, so now we're going to group all these things together based upon the user ID. So it looks like I've got a user ID of 1, 3, and 5. So I can put together my groups here, 1, 3, and 5. Those are my unique user ID values. I'll then assign each of these different rows to one of these groups based upon their user ID. So these first 2 rows go into the first group because they have a user ID of 1. The next one has a user ID of 3 right here, and then a user ID of 5. Then finally, we're going to count up the number of rows in each of these different groups. So once again, it will be a simple count star. It looks like this one has 2 entries or 2 rows inside of it. And then we've got a 1 and a 1. Now finally, we want to do some filtering on these groups. And this step, or this second filter, is going to achieve this step right here. We're going to do some filtering based upon an aggregate function. So this is where we would make use of that having statement. We would say something to the effect of having greater than 2 comments. Well, in this case, looks like we've only got one here that has even 2 comments. So we'll say more than or equal to 2 comments. That'll just make this a little bit easier. So we actually have some useful results. So it looks like we would drop off these 2 right here, and we would be left with just user with ID 1. And so we would select user ID. That would show that user ID of 1 right there. We could also select a count star, and that would display the number of comments that this user had made to the 2 initial photos. Okay, so that's the idea. So now we're going to repeat this process and actually write out the SQL for it. I am going to change the numbers just a little bit to better suit our data set that we are currently working with. We're going to say that we want to find photos where the user commented on the first 50 photos. And we want to find users who added more than or equal to 20 comments. And actually, we'll just go with a straight more than 20 comments on those first 50 photos. Okay, so that's our criteria right there. Let's go write out a query for it. All right. So we would do a select. We'll leave select empty for right now. Like I've said many times before, it's frequently a lot easier to put together all the other statements and then kind of reflect on the data you actually have accessible and then write out your actual selection or the columns that you want to actually display. So we would start off with comments. We would then apply our initial filtering criteria using that where statement. So the goal of that initial where is going to be to make sure that we only take a look at the first 50 photos. So out of all these different comments, we want to find the ones with a photo ID less than 50. And we can make this a less than or equal to 50 or just less than 50. It doesn't really make a difference. I don't really care either way, whether you want it to be the first 50 or 50 inclusive. Either way is totally fine. Then after the where step, we would then do our group by. We're going to group by user ID to find the number of photos ultimately that had been created by each user. So we're going to group by the user ID. And then we're going to do our second filtering step. We know that this second filtering step has to use a having statement or that having keyword because we are trying to do filtering of groups. And in addition, we are doing some filtering that is going to rely upon using an aggregate function. Anytime we're trying to filter groups or anytime we're trying to filter using an aggregate function, we want to think about that having keyword. So in this case, we want to do a having and we want to count each group and find the users that have more than 20 comments. So I'll do a having count star, so that's going to count all the different rows in each of these different groups. We'll say greater than 20. All right, so those are our 2 filter statements. Everything's looking good. Now the last thing we'll do is add in our actual select. In this case, we'll print out the user ID because remember we can only select columns that have been grouped by or are the product of doing some aggregate function. We cannot select any of these inner columns inside of here because we've made use of group by. So I'm going to select the user ID. And then I'll also print out the number of comments that those users made. I'll do a user ID and then a count star to print out the number of comments that each of them created. And let's run this. And there we go. So it looks like for the first 50 photos, user with ID 1 added 23 comments, and user with ID 4 added 22 comments. All right, so that's having. We've now taken a look at 2 examples of it. And again, as I've repeated many times, every time that we are trying to filter groups, we want to think about having. And anytime that we are trying to filter groups based upon some aggregate function, we want to think about having. Let's take a pause here and continue in just a moment. Let's take a look at a quick exercise around the having keyword. So our goal here is to take a table of phones. Once again, this table of phones has a name, a manufacturer, a price, and units sold. I'm going to remind you that spelling the word manufacturer is just a little bit tricky, and as a matter of fact, when I was putting together this exercise, I even mistyped manufacturer myself. So just double check your spelling of manufacturer anytime you write it out. Our goal here is to take a look at that table of phones and print the names of manufacturers and their total revenue for all the phones that they sold. And then we want to do a little bit of filtering here. So we only want to print the manufacturers and their revenue when that manufacturer has a revenue greater than 2 million for all the phones that they sold. Now let's take a look at this in diagram format. If you don't want to watch the diagram, no problem. Just pause the video here and give a shot at the exercise in the next video. All right, so here's our table of phones. The first thing we probably want to do is group all the different manufacturers together. So we can take a look at each manufacturer's group of phones and then run some calculation on each of those groups. So it looks like the unique values here are Nokia, Apple, and Samsung. So we would have groups or buckets of sorts of Samsung, Apple, and Nokia. And I'm going to reduce that font size just so it fits in a little bit better. There we go. So we would then take all these different rows and assign them to a different group. Well, it looks like Nokia first is going to go down into the Nokia bucket. We've then got Apple right here. And then finally, the two Samsung phones are going to go into the Samsung bucket. Now here is our grouped set of phones. As usual, we cannot directly select any of the red columns. We can only select the grouped column or any calculated column or any column that's generated by using a aggregate function. Now we need to somehow find the number of units sold and multiply that by the price, and then make sure that we only take a look at manufacturers with a total revenue greater than 2 million. So I think what we might want to do here, and what I'm about to show you here is going to kind of give away the solution a little bit. So if you want to try this on your own, pause the video now and continue on. What we probably want to do here is some kind of calculation that will be maybe the sum of price times units sold. That's probably what we want to do. If we find the sum of price times units sold, that's going to give us the sum of this times that and this times that. We'll take price times units sold, multiply those numbers together, and then add them. So we'll then end up with a total revenue right here for the Samsung manufacturer. And who knows, maybe that's like 5 million. And then maybe Apple only has 1 million, and maybe Nokia only has 1 million as well. Now we would want to do some filter to all these different groups, and we want to discard an entire set of groups. We don't want to see Apple and Nokia at all. So we would want to somehow drop those groups out and be left with only Samsung. To do that filtering, you're probably going to make use of that new having keyword. Once you do that filtering step, just remember, ultimately you want to print out the name of the manufacturer and the total revenue as well. So make sure you print both those out. All right, so go ahead and give this a shot. As usual, we'll take a look at a solution in just a moment. All right, my friends, let's try out a solution. Well, as usual, I'm going to first put in my select keyword, but I'm not going to select any columns just yet until I have a really good idea of the structure of data that I'm going to end up with. Next, I'm going to specify the source of all the different rows I want to work with. That's definitely going to be all the rows of the phones table. So I'll do a from phones. I'm then going to immediately apply a group by step. So I'm going to group all these rows together based upon their manufacturer. I'll then have those different groups of Apple, Nokia, Samsung, and so on. They'll do a group by manufacturer. And again, double check your spelling on manufacturer right there. We'll then start to filter down these different groups. So anytime that we're doing a filter on a group, we're going to use that having keyword. And then inside this having statement, we want to do some filtering using a aggregate function because we want to sum up the revenue of every phone inside of each group. So I'm going to do a sum of price times units sold. So remember, price times units sold right here, that's going to be executed for every single row. And then the result of that multiplication will all be added together using sum. Okay, so that should be it for filtering out, or getting that initial sum right there. So then to do the actual filter, we only want to take a look at manufacturers where that sum or that total revenue is greater than 2 million. So I'll put in a greater than and then 2 million. I'm only putting in commas just so it's very clear that I'm putting in 2 million here. We can't add in commas in SQL and a number, so I am going to delete those. Okay, so now that we've got that filtering complete, we can now select some actual columns. So I want to see the manufacturer, and then I want to print out that manufacturer's total revenue. So to print out that total revenue, we can do that same calculation once again. So I'll do a sum of price times units sold. And that should be it. All right, so let's check our solution and see how we're doing. All right, looks good. So I've got Apple and Samsung. Looks like they both have revenue greater than 2 million. Well, hopefully you came up with the solution as well. If you didn't, don't sweat it. As usual, you're going to have a lot of opportunities for practice throughout the rest of the course.